board is visible. Um, yeah, you can. All right, go ahead.
I did already.
All right. This is for Aaron and Hannah, and this is our review question from the past. So, can you see it in there? All right. So I won't explain it because I just explained it to the class. And here's the problem. Here's the illustration. Here's the formula, and the answers worked out, and that's in meters. All right. We're going to go on today by going back to where we were on, what was it, the Doppler Effect. Can you find your work on that? I think we were working through some problems on the Doppler Effect. So open your comp books to that area. Let's do one to get, that was kind of a crazy formula, so going around. Morgan, could you read that formula? Do you have it there for me? Let's see, it was frequency heard or observed equals.
Oh, okay, yeah, it was V sound.
Velocity of the sound.
Plus or minus velocity of observer. Over velocity of sound. Plus or minus velocity of source.
All times
F
the true frequency. All right, and this formula showed that how we can calculate the change in pitch as a sound moves toward or away from you. So let's go ahead and do one more of those so we can be reminded how this formula works. Does anyone, Annabelle, you weren't here, did you watch that video?
All right. Sorry.
All right, this is going to be kind of a quick version, so I don't think you'll pick it up in one, but you can go back and watch that. All right, which one did we do last? We did the train. Was that the last one we did? The train, the Chukka train? All right, so this time you are a driver. So, of course, the drawing. My non-smart cars. I gave up all my smart cars. All right, you are a driver. You're driving toward the factory. Factories are always evil looking. All right, there's the factory. You're driving toward the factory, and the temperature is 25 degrees Celsius. And the whistle on the factory goes off. It has a bell, a whistle, or something that sounds when the shift is over. And so the whistle blows. The whistle has a frequency of 494 hertz. That's what it would be if you were still and the factory is still. And I hear the frequency 511 hertz. And that makes sense. Yes?
Are we doing that one thing today that you said, like Mr.
Yeah.
Man's? Okay.
All right. So as we see, we're going toward it. And does it make sense that the frequency went up this time? Because as I approach the sound, the Doppler effect, Annabella, is like when you hear a horn and it's going by you, it goes, meow. It changes pitch. So as you go toward the sound, it goes up. As you go away from the sound, the pitch goes down. And these are the numbers that represent the pitch, and which is frequency. So we're going toward, so we expected the number to go up. So usually you're calculating this. Notice this time I gave you this, so I have another question for you. How fast am I going? My speedometer's broke, so I have to calculate it this way. How fast am I driving? All right, so we're taking the formula that Morgan just read, and we're putting in the numbers where you think they go for a while, and I'll jump in and see if you're going in the right direction in a minute. Right, I noticed that the the frequency that I hear was given as 511, so I'll put in a 511 for this number. And the true frequency I know, so I'll put that in on the other side. This is connected by times. So now I just have to figure out what goes in here and what's missing. So, Alex, do we know the velocity of the sound?
494.
Actually, that's,
that's
a
the frequency.
frequency.
It's a frequency.
Yeah.
The velocity is.
Yeah, this is hidden in here.
Oh.
So what's the formula we need to get the velocity from that? Can you look back and get it for me, because I keep forgetting the number.
I have the answer, but I don't see the formula.
Something with 3's and 0.6's.
Oh, it's all the way back there. 331.5
There it is. That's the number I can't get in my brain.
plus
0.606. Yeah, times t.
times
All right. Were you aware that you have to go to an old friend to find the velocity? So it has to be in centimeters. It has to be in centigrade, Celsius. So that's 25. So I'll replace that t with a 25. Can someone give me that number?
346.65.
346
So
points, so
347.
347, anyone confirm that when it went in? All right, 347 is the velocity of the sound. You're pretty much sure when they give you the temperature that you're gonna have to use that formula. So, all right, plus or minus, we'll come back and decide which we're gonna use there. What is the velocity of the observer? I'll skip you, Annabella, since you haven't seen one of these. Jonathan, what's the velocity of the observer? That's me in the car. What's my velocity?
Okay.
No number was going to match because the question says, how fast am I driving? So that is the unknown. The velocity of the observer is not known, and that's going to be the only number that's not known. So Jonathan, we'll just call that V sub O for velocity observer. Fill in the numbers on the bottom. We know both of those. What's the velocity of the sound again?
347.
And what is, then I'll put plus or minus. And what's the velocity of the sound source? Where's the source means where it's coming from. Where is the sound coming from? In this, the whistle in the factory. Is the factory moving?
Oh no, it's at zero.
Right. So, on the bottom here, when we have a 0, it doesn't matter if it's plus or minus, so it's no use. I'll just pick plus, because plus or minus 0 is the same. Now, on the top, what do we want? Do we want plus or minus? And Annabelle, this is the whole trick to these, is figuring out. Usually our formulas tell us whether it's plus or minus, but this one, in some cases it's plus, in some cases it's minus. So, we notice that this number here times this number here, Brendan, had to become a bigger number, right? So we don't want this to be a small fraction, we want it to be a large number. So do we want plus or minus?
Plus.
Plus. Right, so we kind of have to reason through that. All right, mathematically, back to you. Molly, how do you solve that mathematically? There's several steps you could do first. What do you recommend?
Combining within the parentheses.
All right, and what can
Which
you?
on the bottom, that pretty much is going to be
Okay.
3.
All right. All right, what else?
Then I divide 511 by 4.
No, that's probably a good first step. So let's get rid of the 494. Molly, what fraction or decimal does that turn to be?
1.03.
1.03? All right. I'll do it in pink here since I ran out of board space. So we have 347 on the top plus the velocity of the car of the observer, which is the car, divided by 347. Okay, Molly, finish it mathematically. Next step.
Multiply both sides by 347.
All right, and when I multiply both sides by 347, it disappears from here and appears over here. What is 347 times 1.03?
589.
And last step, Molly.
Subtract 347.
Right, subtract, don't divide there, because it's held to the unknown by addition. And what do you get?
12.
12 miles, or meters. Was this in, what are we working in here? Over here, we were definitely, it's meters per second. All right, that was a little different. We used the exact same formula, but it was a little different in what we were asked for, so be aware that it can go that way as well. Before we leave and enter another discussion today, I want to do one more type of problem. It's not Doppler. I think you're Doppler trained now. All right. Are you one of those people who like thunderstorms or don't like thunderstorms? Some people actually.
As long as there's no lightning.
Well, by definition, a thunderstorm has lightning. So
Yeah, that's why I'm confused.
I like it if it's not too close.
Miss Powell,
Uh-huh.
that 589 is